Topics covered in Chapter Integrals. Okay, so we've laid the groundwork with limits and derivatives, and now we're moving on to the second major topic in calculus, integrals. This slide gives you an overview of what we'll be covering in this chapter. Think of calculus as having two main sides: differentiation, which we just finished, and integration. They're closely related, almost like reverse operations of each other. Differentiation helps us find the rate of change of something at a specific moment. Integration, on the other hand, helps us find the accumulation of a quantity over an interval. This chapter will take us from understanding what integration is, which is finding antiderivatives, essentially undoing differentiation, to actually doing integration and applying it to solve problems. We'll start with the theory and then move into practical applications. Now, let's look at what you'll be able to do by the end of this chapter. First, we'll solidify the concept of integration as the inverse of differentiation. Then, we'll learn a bunch of techniques for solving different types of integrals, things like substitution, partial fractions, and integration by parts. Don't worry if those terms sound intimidating now, we'll break them down step by step. We'll also look at integrating specific types of functions, like algebraic and trigonometric functions. A key concept we'll explore is the definite integral, which allows us to find the area under a curve. And tying everything together is the fundamental theorem of calculus, which shows the beautiful connection between differentiation and integration. Finally, we'll learn how to use the properties of definite integrals to make our calculations more efficient. Essentially, this chapter is about building a solid foundation in integration, so you're prepared for more advanced math and science courses. And as you'll see on the next slide, integration isn't just a theoretical exercise, it has tons of real-world applications. Real-world applications of integration. Okay, so we've just discussed what integrals are, essentially the reverse of derivatives, and how we'll be learning to calculate them. Now, let's talk about why this is important. This slide highlights the real-world applications of integration, and honestly, it's used everywhere. It's not just an abstract math concept, it's a powerful tool in fields like physics and engineering. For example, if you have a graph showing an object's velocity over time, integration lets you figure out how far that object traveled, its displacement. Similarly, you can find velocity from an acceleration graph. It's also crucial for things like calculating the center of mass of an object or the work done by a force that changes over distance. But it doesn't stop there. Architects and civil engineers use integration to calculate areas of oddly shaped land or the volumes of complex buildings, ensuring everything is structurally sound and uses materials efficiently. In economics and finance, integration helps determine total costs or revenues from rates of change, and even analyze market dynamics like consumer and producer surplus. Even in biology and medicine, integration plays a role, modeling how populations grow, tracking the amount of a drug in your system over time, or analyzing heart function. The key takeaway here is that mastering integration gives you the ability to model and solve problems involving things that are constantly changing. It's a fundamental skill for anyone pursuing studies in science, technology, engineering, or mathematics, the STEM fields, and will open doors to more advanced concepts down the line. So, as we move forward in this chapter, remember these applications. They'll help you see the bigger picture and understand why we're learning this.